Hey everybody, welcome back to Beginning Algebra. Today we're in section 1.7 and we're going to be talking about properties of real numbers. These are rules that all numbers have to obey, and we're going to look at three properties: the commutative property, the associative property, and the distributive property. All three of these are necessary for simplifying algebraic expressions and for solving equations, which is where we want to eventually get to. So let's go ahead and look at these three very important properties. Okay, so like I said, all numbers have to obey certain rules, and these rules are called properties. And we're going to look at three: the commutative, the associative, and the distributive property. Now, we all use the word commute in everyday conversation. You know what it means to commute to work. It means to change locations. You change your location from your home to your work. And in algebra, we have a commutative property of addition and also a commutative property of multiplication. And this is all the commutative properties say. They say that if two numbers are added or multiplied in either order, the result is the same. This is something you already knew. This is not news to you, I know. So here are the commutative properties. The commutative property of addition is that A plus B is equal to B plus A. You already knew that. You knew that 3 plus 5 would be equal to 5 plus 3. So you know that changing the order of the addition doesn't matter. That's all the commutative property says. And just keep in mind, commute means to change locations. So the commutative property has to do with changing the location of the numbers. And then we have the commutative property of multiplication, which says that A times B is equal to B times A. So here's our first example, and the instructions say use a commutative property to complete each statement. Okay, we know that commutative property means the numbers change position. So in part A, we have negative 8 plus 5. Okay, that can be rewritten as 5 plus negative 8. Now notice they did not ask us to evaluate what 5 plus negative 8 is. It just said to use a commutative property to complete each statement. So that's where we're going to stop right there. And on part B, we have negative 2 times 7. And using the commutative property to change the position of the numbers, we can say that negative 2 times 7 is equal to 7 times negative 2. And so this is all there is to the commutative property. Now let's talk about the associative property. So when we associate one object with another, we think of those objects as being grouped together. The people you associate with are the people in your group. So the associative property always involves grouping symbols. And the associative properties say that when we add or multiply three numbers, we can either group the first two together or group the last two together, and we'll get the same answer either way. And again, I'm sure this is something you already knew, although you might have never thought about how to write that down in algebra symbols. So here it is, the associative property of addition and the associative property of multiplication. The associative property of addition says that if you have A plus B plus C, you can either group the first two numbers together, see that's what the parentheses are indicating here, or you can group the last two numbers together. So if you think about how we would have to work this problem with order of operations, the parentheses here say add the A plus B first and then do that sum plus C. The parentheses here say work B plus C first and then do A plus that sum. So what the associative property is telling us is that as long as all the numbers are added together, it doesn't matter how you group them. And notice that the order of the numbers does not change when we have the associative property, because if the order changed, we would be throwing in the commutative property, and we don't want to do that right now. So this is the associative property of addition, and then the associative property of multiplication is the same thing, but for multiplication. So if you have A times B times C, you can either group A times B together and do that first, or you can group B times C together and do that first, and whichever way you group it, you'll get the same answer. So here in example 2, let's use the associative property to complete each statement. Now remember, in the associative property, we will not change the order of the numbers because that would be the commutative property. We will only change what's grouped together. So in part A here, this is where we want to demonstrate the associative property of addition. We have -8 plus parentheses 1 plus 4. Now if I leave the numbers in the same order, but I group the first two together instead of the last two, then we'll have parentheses -8 plus 1, close the parentheses, and then plus 4. And so let's think about this. Let's work it out and just make sure that it's true. If we look at the left side of the equal mark, 1 plus 4 is 5. Then -8 plus 5 would be -3. If we look at the right side of the equal mark, -8 plus 1 is -7, and -7 plus 4 is -3 as well. So both sides work out to the same thing, therefore they are equal. And now let's look at part B. This is multiplication. So if we have bracket 2 times -7, close the bracket, times 6, we can use the associative property to rewrite this if we just move the bracket to include the last two numbers instead of the first two. So we'll have 2 times bracket -7 times 6, close the bracket. So again, notice how in each case the order of the numbers did not change, but only what was inside the grouping symbol changed. Now here is example 3, and on this one we're going to decide whether each statement is an example of a commutative property or an associative property or both. So keep in mind that on the commutative property, the order of the numbers has to change. On the associative property, what's put in the grouping symbols has to change. So let's look at part A. Here we have parentheses 2 plus 4, close the parentheses, plus 5 equals 2 plus parentheses 4 plus 5. So first, let's see if this is commutative. The numbers on the left are in the order 2, 4, 5. The numbers on the right are also 2, 4, 5. So this is definitely not an example of the commutative property because no numbers changed their position. However, look at the parentheses. These parentheses contain 2 plus 4. These parentheses contain 4 plus 5. So the grouping has changed. So this is an example of the associative property. Now look at part B. Here we have 6 times parentheses 3 times 10 equals 6 times parentheses 10 times 3. So this time, if we check the order of the numbers, you'll see that we have on the left 6, 3, 10, and on the right 6, 10, 3. So the contents of the parentheses didn't change, but the order of the contents of the parentheses did change. So whenever the order changes, that's an example of the commutative property. And now let's look at part C. Here we have parentheses 8 plus 1, close the parentheses, plus 7. And that's equal to 8 plus parentheses 7 plus 1. Now ask yourself if the order of the numbers has changed. Here we have 8, 1, 7. And on the right we have 8, 7, 1. So definitely the order has changed. Let's also ask ourselves if the contents of the parentheses has changed. These parentheses contain 8 and 1. These parentheses contain 7 and 1. So not only has the order of the numbers changed, but the grouping has also changed. So this is actually an example of both properties being used at the same time. Now, one of the really convenient uses of these properties is that sometimes we can rearrange and regroup numbers to make it easier to do calculations mentally. So let's look at example 4 and let's find each sum or product, thinking about how we might rearrange and regroup to make things easier. See, here in part A, we have 23 plus 41 plus 2 plus 9 plus 25. Now you can just do each addition from left to right and you will get the right answer, but you might have to think about it harder than you would if you just take a minute and notice that 23 plus 2 would make 25, and that's a nice, easy number to work with. So I'm going to rewrite this so that these two numbers are next to each other. And also, if you'll look at 41 and 9, you'll notice that 41 plus 9 is going to make 50, another convenient number to work with. So let's go ahead and put these in that new order, and then let's group the 23 and the 2 together, and let's also group the 41 and the 9 together. Okay, now 23 plus 2 is 25, 41 plus 9 is 50, and then we have our 25 here. Now I'm not going to write this down, but notice that we could also rearrange these three numbers so that the 25s are together, and then 25 plus 25 would be 50, and 50 plus another 50 would be 100. If you just work left to right, then 25 plus 50 is 75, and 75 plus 25 is 100. Now, in order to rearrange and regroup, was it necessary to actually write it down? No, it wasn't, and we could have done this rearranging mentally, but we just wrote it down here to demonstrate the properties that we're using. Going forward, we won't really need to actually write down when we change the order. And let's look at part B. Here we have 25 times 69 times 4. Now I'm sure you can imagine that if you had to work out 25 times 69, that would be a little bit of a complicated problem, because you'd have to write it down and do all of the multiplying and carrying and so forth that comes with multiplying two-digit numbers together. But I noticed that here we have 25 and 4. So 25 times 4 is an easy multiplication to do because 25 times 4 is 100. So let's change the order here so that we have 25 times 4, and then let's put the 69 here. And notice that I've also gone ahead and grouped the 25 and the 4 together. And now 25 times 4 is 100, and then 100 times 69 is 6,900, or we could say 6,900. All right, now let's talk about the distributive property. The distributive property is the only one we have that involves both addition and multiplication. Whenever you have a sum or difference inside parentheses, and you have a factor outside the grouping symbol that's being multiplied by the entire contents of the grouping symbol, then you have a chance to use the distributive property. So the distributive property allows us to multiply a factor through a group of terms so that the parentheses are no longer necessary. This is a way of clearing the parentheses, we would say. So what we would do is multiply the 2 times each individual part of the sum inside the parentheses. So we would have 2 times 5, and then plus 2 times 8. And we could write it like this: 2 times 5 plus 2 times 8. And then we could evaluate each of these multiplications. So 2 times 5 would be 10, and 2 times 8 would be 16, and then 10 plus 16 would be 26. Now, if you think about it, that's the same answer we would have gotten if we had worked the inside of the parentheses first and then multiplied 2 times our total here. We would have 5 plus 8, which is 13, and then 2 times 13 would be 26. So we get the same result either way. Sometimes students will ask me on an expression like this, do I have to distribute? Or can I distribute, or do I have to work the operation inside the parentheses first? And the answer is, this is one of those places in algebra where you have a choice. There's no right or wrong. You can do whichever seems easier to you. Does it seem easier to multiply 2 by each of these individual numbers and then add the products together? Or does it seem easier to do the addition first and then multiply the total by 2? Totally up to you. And so for that reason, on a problem like this, we really don't need the distributive property. However, if we're going to eliminate parentheses, we really do need the distributive property whenever we have expressions with variables. So the distributive property is optional when you have all numbers, but it's necessary when you have expressions with variables and you have a factor outside a grouping symbol multiplied by a sum or difference inside a grouping symbol. So here's what the distributive property looks like in general terms. If you have a number A, multiplied by a sum, b plus c. Then what you're going to do is multiply a by each part of the sum. So you're going to have a times b plus a times c. And it works this way too. If you have it written where it's parentheses times a, you can distribute from the right as well. So in this case, you would get b times a plus c times a, which you see here. And in both of these cases, we would say that the a outside the parentheses is being distributed over the b and the c inside the parentheses. So here's example 5, and we're going to get plenty of practice using the distributive property, because all the way through your algebra sequence, you'll see that it's necessary to use the distributive property to clear the parentheses very frequently. So here we go. On part A, we have 5 times 9 plus 6. Now I recognize, and I want you to recognize, that we could perform this addition first, but if we do that, we won't be using the distributive property. So let's use the distributive property to multiply 5 by each of these terms inside. So we would have 5 times 9 plus 5 times 6. Okay, now each of these multiplications can be evaluated. So 5 times 9 is 45, and 5 times 6 is 30. And of course, 45 plus 30 is 75. Now, on part B, we have 4 times x plus 5 plus y. So these parentheses are necessary to show that 4 is being multiplied by the entire sum. Now notice that we would not be able to use order of operations to complete this sum here. Now notice that we would not be able to use order of operations to evaluate this sum right here, because we don't know the value of x and we don't know the value of y. So how can we know the value of x plus 5 plus y? So if we want to clear these parentheses, what we'll have to do is use the distributive property to multiply the 4 times each individual part. So we'll say 4 times x is 4x plus 4 times 5 is 20 plus 4 times y is 4y. And now notice that we have 4x plus 20 plus 4y, and there's no way for us to combine these any further because we don't know what x is, therefore we don't know what 4 times x is, and we don't know what y is, therefore we don't know what 4 times y is, and therefore how can we add these numbers together when we don't know what they are? So we just have to leave this sum like this. Okay, now on part C, we have negative 2 times x plus 3. So notice that we can't get a total for x plus 3 because we don't know how much x is worth. So if we want to eliminate parentheses, all we can do is multiply the negative 2 times each individual part. So negative 2 times x would just be written negative 2x, and then plus negative 2 times 3 would be negative 6. Okay, now there's really no benefit to leaving this in this plus negative 6 form. Remember that plus a negative is the same as saying minus, and minus is easier to read. So let's just rewrite this so that it says negative 2x minus 6. And again, you know that minus 6 has the same value as saying plus negative 6. It's just that this is a little easier to read. Okay, now let's look at part D. Here we have negative 1/2 times 4x plus 3. Okay, let's multiply negative 1/2 times each of these numbers inside the parentheses. So first I'll have negative 1/2 times 4x, and then we'll have plus negative 1/2 times 3. So we've multiplied the negative 1/2 times each of the terms inside the parentheses. Now we have to simplify this. So remember, for fractions, we do top times top and bottom times bottom, and the bottom here is not visible, but we know it's an understood 1. So in the top, we'll have negative 1 times 4 times x. We could just write that as negative 4x. And in the bottom, we'll have 2 times 1, and we can just write that as 2. Then we have plus negative 1/2 times 3. And again, negative 1 times 3 is negative 3, and in the denominator 2 times 1 is 2. So we have negative 3 over 2. Okay, now let's simplify this even further. We know that 4 divided by 2 reduces to just 2. 4 divided by 2 is 2. So that will give us negative 2x for this first term. And then here we have plus negative 3/2, and we know that an easier way to write plus a negative number is just to say minus that number. So now we'll say minus 3/2. And this is all we can do to this expression. Okay, now we're still on example 5, but here we have 4 more expressions that you can apply the distributive property to. And I think that at this point you could pause the video and try these on your own and see how you do, and then you could go through them with me and just check your answers. So now I'm going to work them out one at a time. Here we have 3 times k minus 9. So we could say 3 times k is 3k, and then we have minus 3 times 9 is 27. So we end up with 3k minus 27. And you can't actually do this subtraction because you don't know what 3 times k is. So you just have to stop here. This is all we can do to this one. On part F, we have negative 2 times 3x minus 4. Now if you wanted to, you could restate this as 3x plus negative 4, but I hope you won't do that. The easiest thing really to do is just to treat this minus sign like a negative, because you know that this can be rewritten as plus negative 4. So don't actually do the rewriting, but just treat it like a negative. Now we'll have negative 2 times 3x, and that's going to be negative 6x. And here we'll have negative 2 times negative 4, and we know that negative times negative is positive, so that's going to give us positive 8. So do you see that if we just treat this like a negative, the sign kind of takes care of itself? So we end up with negative 6x plus 8. Now here on part G, we have 3 terms inside the parentheses, but that's really no big deal. All we have to do is multiply 8 by each piece. So we'll have 8 times 3r, that's going to be 24r, and then we'll have plus 8 times 11t, and that's going to be 88t, and then we'll have plus 8 times 5z, and that's going to be 40z. So here we have 24r plus 88t plus 40z, and since each of these terms contains a variable, there's nothing we can do to combine these any further. Okay, now on part H, we have negative 2/5 times 10b plus 20a. So what we'll do is we'll multiply negative 2/5 times each of these two things inside the parentheses. So I'll have negative 2/5 times 10b plus negative 2/5 times 20a. And now we'll go back and perform each of these multiplications. But before we do the multiplication, we will try to simplify the fraction so that the denominator possibly goes away. So here I have negative 2 times 10b divided by 5. Notice that the 10 and the 5 can both be divided by 5, so we should do that. 10 divided by 5 is 2, and 5 divided by 5 is 1. So now what we actually have here is negative 2 times 2b. That's going to make negative 4b. And in the denominator, we have 1 times 1, which equals 1. So there's no need to write the denominator now. So we'll have negative 4b for this first multiplication. Then we have plus. Now for this second multiplication, we have negative 2/5 times 20a. Again, notice that the 20 in the top and the 5 in the bottom can both be divided by 5. If we do that, 20 divided by 5 would leave 4. And 5 divided by 5 would leave 1, which is good news because now the denominator is just 1 and we won't need to write it. So we're going to have here negative 2 times 4 times a, that's negative 8a. Okay, now so far we have negative 4b plus negative 8a, and remember that instead of writing plus negative, we always change that back to just minus. So we'll end up with negative 4b minus 8a. Now, a lot of times you'll see a pair of parentheses with only a negative in front of it and no number. So in this case, we're saying minus everything in the parentheses. So if there is only a negative in front of a pair of parentheses, you treat that like it's a -1 coefficient and you distribute the -1. Now, you don't actually have to write the 1 here, but if it helps, you can do that. I like to just leave it like that and mentally multiply each piece times -1. Now, what happens when you multiply a number times -1 is it stays the same number, it just changes its sign. And on pluses and minuses, what that ends up doing is just changing each operation to the other. So let's look at this together. We're going to have -1 times 3x. That's going to make -3x. And then we have -1 times positive 5y. That's going to make -5y. So I'm just going to write minus 5y. And then we have -1 times -8. And we know negative times negative is positive, so that's going to make this plus 8. So again, multiplying a pair of parentheses by a negative just changes all the signs inside the parentheses. Positive 3x became -3x. Plus 5y became minus 5y. And minus 8 became plus 8. And now here are a few for us to practice on. It says rewrite each expression without parentheses. You can think of this as distributing a -1, or you can just say to yourself, I'm just going to change all the signs. So negative parentheses 2y plus 3 becomes -2y minus 3. Easy peasy. On part B, negative parentheses -9w minus 2 becomes positive 9w plus 2. And on part C, negative parentheses -x minus 3y plus 6z becomes positive x plus 3y minus 6z. And so you see that distributing a negative really just has the effect of changing all the signs.